Hello everyone, welcome to the ITLS Academy. Today we are going to discuss the topic that is your determination of nitrate by the method that we are going to use is a cadmium reduction method. Okay, so what we have to do, we have to determine this nitrate content into a water. Nitrate content into a water, and the method that we are going to use is a cadmium reduction method. Okay, so before starting the lecture, we have to see that the introduction part of it. Determination of the nitrate, and the formula of this nitrate is NO3. Okay, is difficult because the relatively complex procedure required. Okay, for the determination of nitrate, we required a complex procedure. Okay, the high probability that interfering constitute will be present and the limited concentration ranges of the various techniques. Nitrate is the most highly oxidized form of nitrogen. Okay, this nitrate are what? They are highly oxidized form of the nitrogen compound commonly present in a natural water, and they are commonly present into a natural water. Present into a natural water. Okay. Significant sources of this nitrate are chemical fertilizer, decay vegetables, animal matter, domestic effluent, sewage sludge disposal to the land, industrial discharge, leakage from the refuse dumps, and atmospheric washout. They are what? They are the common source of the nitrate into the water. Now, depending upon the situation, these sources can contaminate the streams, rivers, lakes, and groundwater. Unpolluted natural water also contain a minute amount of this nitrate. Excessive concentration in drinking water is considered hazardous for infant. Okay, if infant drink this water in which the concentration of the nitrate is very high, so it will consider as a hazardous for them because of its nutrient taken up by the plant and converted into a cell protein, and the growth stimulation of the plant, especially of algae, may cause objectable eutrophication. Now the next is your scope. Prescribe cadmium reduction method for the determination of the nitrate. Okay, this method is suitable to determine the nitrate concentration even below the 0.1 milligram per liter of nitrate nitrogen. Suppose that we have a 1 liter of water. Now this cadmium reduction method can detect even 0.1 milligram or even below of it as per liter. The concentration of the nitrate below 0.1 milligram per liter. Okay, it can be determined by this cadmium reduction method. Principle. Nitrate is reduced to nitrite in the presence of cadmium. Okay, so we all know that this nitrate are converted, or you can say that reduces into the nitrite due to the presence of cadmium. The nitrite produced is determined by the diazotizing with sulfanilamide and coupling with an an ethylene diamine, so that it will form a highly colored azodide. Highly colored azodide, and this dye can be measured with the help of the instrument that is called a colorimeter, or it can be measured by a colorimetric. Okay, simply nitrate converted into one reduces into a nitrite due to the presence of cadmium, and this nitrite, the production of this nitrite are determined by the diazotizing with the sulfonamide with and coupling with an ethyl diamine so that it will form a colored dye that is called a azo dye, and it can be measured by a colorimetrically. Okay, now the next is your interference. If there is a high concentration of the copper, iron, etc., then it will lower the reduction efficiency. That means that this, we all know that nitrate reduces into the nitrite. Okay, nit just a minute. Nitrate reduces into the nitrite. Okay, now if there is a high concentration of copper and iron are present in the sample, then it will reduce, it will lower the this reduction efficiency. So for this we add a ADTA, and this ADTA remove the concentration of copper and iron. Oil and grease and residual chlorine can also interfere. Okay, this oil and grease and residual chlorine can also interfere this um, this nitrate reduction into a nitrite, and it can be removed. Oil and grease can be removed by the method that is called a extraction with the organic solvent, and the residual chlorine are removed by adding a sodium thiosulfide. The sodium thiosulfide remove the residual chlorine, and oil and grease can be removed by the extraction method, and here extraction method we use a organic solvent. Now the next is your apparatus used for this experiment. The first apparatus that we required is a reduction column. So this reduction column are commercially available. One, or construct the column from 100 ml of volumetric pipette. Okay, either they are commercially available, or either you can construct it with the help of 100 ml of volumetric pipette by removing the top portion. When we remove the top portion of the volumetric pipette, then it will convert it into a reduction column. Now this column can be constructed by the two pieces of tubing joined end to end. Okay, join 10 centimeter length of 3 centimeter internal diameter tubing to a 25 centimeter of length of 3.5 centimeter of internal diameter tubing. A liquid leveling device is useful for this purpose. Okay, now the next one is your colorimeter. One of the following. One is your spectrophotometer and one is your filter photometer. Okay, if we use a spectrophotometer, then it should be measure the wavelength around 543 nanometer with a light path of 1 centimeter or longer. If we use this filter photometer, then provided with a yellow-green filter which having a maximum transmittance near a 540 nanometer and a light pathway of 1 centimeter or longer. Now the next is your reagent used in this experiment. So the first reagent that we required is a nitrate-free water. Okay, for this, what we have to do, we have a reagent blank should be prepared. Okay, and this should be prepared with a water whose should not exceed 0.01. Use for all solution and dilution. The next that we required is a copper cadmium granule. For this, first of all, we take a cadmium granule around 25 gram, and it will be taken by 40 to 60 mash, and we have to wash it. After washing, we add we again we wash it with the 6 normal hydrochloric acid. Okay, we take a 25 gram of 40-60 mesh of cadmium granule and wash it with the help of 6 normal hydrochloric acid. Then after that we rinse it with the water. Now swill the cadmium with 100 ml of 2% of copper sulfate solution for a 5 minute, and we do it until we get a blue color partially fades. Decan repeat with fresh copper sulfate until a brown colloidal precipitate develop. Then wash this copper cadmium with a copiously with water at least 10 times so that all the precipitated of the copper will removed. This is how we prepare this copper cadmium granules. The next reagent that we required is a sulfonamide reagent. For this, we have to take a 5 gram of sulfonyl sulfonylamide, and then we add a 50 ml of concentrated HCl. Okay, then after that we add a 300 ml of water, then dilute it with the help of 500 ml of this water, and this reagent can be stable for a month. Okay, this is how we prepare a sulfonylamide reagent. Okay, the next reagent that we required is a N1-naphthyl ethyl diamine dihydrochloride, that is also called a net dihydrochloride solution. Okay, for this we required a 500 ml of water. Then into it we are going to add a 500 milligram of net dihydrochloride. Then it should be stored into a dark color bottle and replace as soon as brown color develop. Okay, we put it this solution into a dark color bottle, and when a brown color are developed, we remove the solution from this dark color bottle. Now the next is your ammonium chloride solution. For this ammonium chloride solution or EDTA solution, for this we required a again 900 ml of water, and into it we are going to add a 30 gram of ammonium chloride and 1.7 gram of disodium ethyl diamine tetraacetate. Okay, when it is completely dissolved, then we adjust its pH with the help of liquid ammonia 8.5. Okay, we have to set its pH around 8.5 with the help of this liquid ammonia. After adjusting its pH, we dilute it to 1 liter. Okay, so remaining the distilled water will be added. Then um, dilute 300 ml of the above solution to a 500 ml with water to get a dilute solution. So we have to prepare this solution dilute in a dilute form. So for this we take it 300 ml of this solution and add 500 ml of water. Then the dilute solution of this ammonium chloride EDTA solution will prepare. The next reagent that we required is a hydrochloric acid of 6 normal. How we prepare it? You can see the video of solution preparation. This is how you know that how we prepare the solution. The next that we required is a copper sulfate solution of 2% M by V, that is mass by volume. So for this we required a 2 gram of this copper sulfate and dissolve into a 100 ml of water. This is how we prepare the copper sulfate 2%. The next reagent that we required is a stock of nitrate solution. For this, we required a dry potassium nitride. And how we dissolve it, we already, how we dry it, we already discussed it. We put it into a hot air oven for 2 hours, then it will dry. Then we take a 500 ml of water, and into it we are going to add a 0.7218 gram of dry potassium nitrate, and then preserve with 2 ml of chloroform per liter. Then we add a 2 ml of chloroform. Okay, so for now we dilute the stock solution of the nitrate. For this we take a 50 ml of stock solution and then add a 500 ml of water. Then we get a standard solution of this. The next is stock solution of nitrite solution. For this we take a 0.6072 gram of dry potassium nitrite in a nitrate free water and make a volume 100 ml. Again, we add a 2 ml of chloroform so that for the preservation purpose and keep it inside the refrigeration. Okay, so this stock solution of the nitrate can be stable for a 3 months. Okay, now we have to dilute this stock solution of the nitrite. For this, we take a 50 ml of this stock solution and add a 500 ml of nitrite free water. This is how we prepare it. The next is your procedure for this experiment. The first one is your preparation of reduction column. Insert a glass wool plug into the bottom of the reduction column and fill with the water. Now add a sufficient column copper cadmium granule so that it will produce a column around 18.5 centimeter long, and maintain a water level above copper cadmium granule so that it will prevent the interrupted of air. Now wash the column with the help of 200 ml of dilute ammonium chloride, that is called a EDTA solution. Activate the column by passing 100 ml of solution comprising of 25 ml of 1 milligram of nitrogen per liter standard and 75 ml of ammonium chloride EDTA solution through it. 7 to 10 ml per minute. Then next is your treatment of this sample. If there is a turbidity or the suspended solids are present in that solution, then we have to remove it by filtering the solution. And the filter paper that we use, its pore size will be 0.45 micrometer diameter membrane or a glass fiber filter. Now after that we have to adjust its pH 7 and 9, which is very important. Then we take a 25 ml of sample or a portion, then we dilute it with the 25 ml, add 75 ml of ammonium chloride EDTA solution and mix. Now pour mix sample into a column and collect at the rate of 7 to 10 ml per minute and discard first 25 ml. After that you have to collect the rest in original sample flask. There is no need to wash the column between the sample, but if the column are not to be reused for several hours or longer, then you have to wash it with the help of 50 ml of dilute ammonium chloride EDTA solution. Now store the copper cadmium column in this solution and never allow it to dry. Now the next is your, as soon as possible and not more than 15 minutes after the reduction, you have to add a 2 ml of sulfonamide reagent to a 50 ml of sample. If we have a 50 ml of sample, then we have to add a 2 ml of sulfonamide reagent. Then after that, you have to kept it for 2 to 8 minutes so that the reagent will react with the sample. Now after that, you have to add a NADA dichloric acid solution into it, and the amount of this NADA dihydrochloric acid is about 2 ml. Then after that, take a absorbance between 10 minutes to 2 hours at 540 nanometer. And you have to also take a distilled water as a blank reagent. Now, using a standard nitrate solution, prepare a standard in a range of 0.05 to 1 milligram of nitrogen per liter by diluting the following volume of standard 200 ml in volumetric flask, that is around 0.5, 1, 2, 5 and 10 ml. Now carried out the reduction of standard exactly as described for the sample and compare at least one nitrite standard so that it will reduce the nitrate standard at the same concentration to verify the reduction column efficiency. Reactive, reactivate, reactivate copper cadmium granule with the help of reduction efficiency fall below the 75%. So this is how the procedure of this experiment are done. The next and the last one is your calculation. Obtain a standard curve by plotting the absorbance at standard against a nitrate nitrogen concentration. Okay, you have to draw a graph between the absorbance and a nitrate nitrogen concentration and compute the sample concentration directly from a standard curve and report as a milligram of oxidized nitrogen per liter, unless the concentration of the nitrite nitrogen is separated and then determined and corrected for. So this is about all the calculation part and all about the determination of this nitrate with the help of cadmium reduction method. I hope you will understand, but if you have any query related to this topic, you can ask me in a comment box or you can follow You can follow the ITLS Academy on different platforms, that is Instagram, Facebook, Twitter, YouTube, WhatsApp, LinkedIn, and subscribe ITLS Academy on YouTube and get our app from a Google Play. Or you can also ask your query to the helpline number that are already mentioned in your slide, that is 7080833450, and visit our website www.itlsacademy.com. Thank you for watching. Please like, share, and subscribe our channel.